Hi, welcome back to the channel. So let's get to look at question 6 of the worksheet that we have right here, which is requiring us to use the Runge-Kutta methods of order 4 to approximate the solutions um, of the given IVPs, and we have to make a comparison of that approximation to the actual solution, like the actual values that you're going to get from the actual solution that we have. So on each of them, like we have question 6a, we have this differential equation right here. Okay, we have each of them, we have a differential equation. This one is this one, then this part is the actual solution, so we use this one to approximate, then this gives us the actual values. Similarly, this one is the differential equation, then this part gives us the actual values. Okay, so I'm going to use question 6b. Okay, I'm going to use question 6b to answer this question. Okay, but before I do that, maybe I will just give a little bit of an intro of what Runge-Kutta methods of order 4 are. Okay, so of course, uh, when it comes to these methods, what all we are trying to do is to gain higher accuracy. Okay, maybe that's how I can simplify it. Gain higher accuracy. Okay, so we are looking for higher accuracy, hence uh, we are to use the Runge-Kutta methods of order 4. Remember, there is Euler's method. Okay, there is also Taylor's method. So each of these have advantages to some degree. Okay, but when it comes to Runge-Kutta's methods, on this particular example that we are doing, we are looking for higher accuracy. Okay, so what are among the things that we need to take note as we use Runge-Kutta's methods? So basically, we know that our W naught is just going to be equals to alpha, and this is when you have the initial condition where y of a is equals to alpha. Okay, then what else do we have to know? Usually the value of h we are given, and of course our ti is equals to a plus ih. Okay, where our I of course starts from what? Starts from 0 and keeps on going like that. Then another thing we have to take note is that our t, okay, our t is given between a and b. So this a right here is the initial, like, is the lower limit in the interval that you are given. Okay, so what computation, I mean what expression that we use to come up with our computation is basically wi plus 1. Oh, let me try to move a little bit up. We have wi plus 1, which is basically equals to wi plus 1 over 6, then open bracket, you're going to have your k here plus 2k2 plus 2k3 plus k4, like that. Okay, so it basically means that um, you just have to come up with your values of k1, k2, k3, and k4. So how do we come up with these values? So um, our k1 right here is simply um, h multiplied by f of ti comma wi, like that. Okay, our k2 is equals to h times f of, you're going to have your ti plus h over 2 comma w1 plus 1 over 2 times k1, which is basically more like k1 divided by 2. Okay, I'll just say k1 divided by 2, like that. Then what about our k3? K3 will be equals to um, K3 will be equals to h times f of, this part remains the same, ti plus h over 2 comma wi plus k2 divide by 2, like that. Then our k4, okay, k4 is equals to h times f of, you're going to have your ti plus h comma wi plus k3, like that. On that part we don't divide by 1, I mean by 2. So uh, sometimes you might find that k4 is written as h of f of, you have your ti plus 1, like is t sub I plus 1, more like that. Okay, instead of the way I've written it, but like the other part remains the same, meaning here it remains the same as it is here. But what's the difference? If you observe me, I've written it as ti plus h, but here is like t sub I plus 1. Okay, so this is one and the same thing. So if you observe here, this part here, this is what our ti is. Okay, so ti is equals to um, a plus uh, a plus h there, like that. Okay, so this is what ti is equals to. So if you observe, when you say ti, so like t sub I plus 1, it simply means, like if I bring it here, t sub I plus 1 is equals to, I'll say a plus, which is like the initial limit, like the lower limit. Then I'll say h, it simply means where there is I need to substitute I plus 1. This is what that expression means, like this part, that's what it means, this sub that you have right here. So it simply means, like here you're going to have your a plus, you just distribute, like you multiply by h, you expand, so it will be ih plus h. So if you can see it clearly, this part here is simply ti, or t sub I. So it's simply t sub I plus what, plus h. Hence I'm writing it like that. So if you find it like this or like that, it simply means one and the same thing. Actually, for me, I find it much convenient because I easily know what ti is equals to, and I know what h is equals to. So I just add them together rather than having for me to come back and write this whole expression again. And yeah, so this is basically the few things that you have to remember, or you have to take note as you are using the Runge-Kutta's methods of order 4. So this is what we are going to be using for our iterations. Then these are the values of k that we have to be finding. Okay, so let's go ahead and look at our example. So our example has the differential equation y prime is equals to minus y plus t times the square root of y. Okay, the square root of y. So the interval t is between the interval 2 comma 3. Then you are given the initial condition y of 2 to be equals to 2. So h is given as 0.25. Okay, then you're also given the actual solution. So the uh, actual solution is given as y of t is equals to, you have open bracket, you have your t minus 2 plus the square root of 2 times e to the power minus t over 2. Then everything here is raised to the power 2, like that. That's our actual solution. Okay, so if you observe, I basically have everything that I need here to get started. So one thing again to take note or to remember is that our ti is equals to a plus ih. So let me begin by computing what my values of uh, my values of t. Okay, so basically starting from t naught. So we're going to say t naught, this is when I is equals to 0. So your t naught will be equals to, maybe let me generalize it just here. Since it's a plus ih, our a is a 2, which is this one right here. Then our h is 0.25. Then we place I there. So if I is 0, it basically means t is equals to, I mean t naught is equals to 2. So we say t naught is equals to 2. What about t1? T1 is just a matter of you substituting 1 here. So that would be like 1 multiplied by 0.25. That would be 0.25 plus 2. That would be 2.25. Then let's go to T2. T2, uh, T2 plug in 2 where there's I. That's going to be 2 times 0.25. That would be 0.5 plus 2. That would be 2.5. Then T3, it will be 2.75. meaning t4 will be equals to what? Will be equals to 3, which is the highest limit that we have right there. Okay, let's go ahead and work this out now. So first of all, you observe to say it's just a matter of us coming up with the values of k1, k2, and k3. Okay, so we should also take note that our w naught is equals to what? Is equals to a 2, which is this one here. Okay, so let's go ahead and find our k1. So how I write this myself is that my k1 I'm going to say is equals to h times f of ti comma wi. This we know, I wrote it already earlier. Okay, so this I'll just say is equals to, what is our h? Our h is equals to 0.25. Okay, is equals to 0.25. Then I'll say f of, so it's ti comma wi. But remember, in this case, what we are doing right here, or let me try to write it this way, maybe to be more clear. I'll say the first step that we are taking, we are using t naught is equals to 2, and we are using w naught is equals to 2. That's the first thing that we are doing. Okay, now let's work it out. So we say our k1 is equals to, is h, which is 0.25 times f of ti. Okay, what is our ti? In this case is t naught, which is 2, comma wi, which in this case is still w naught. So this will be equals to, I'll say 0.25 open bracket. It simply means these that I have right here, I need to substitute in this differential equation. So it will be more like minus y. Where there is y, we substitute with w naught, and where there is t, we substitute with ti, or t naught in this case. So that would be 2 plus t is also 2 in this case. I'm just looking at this 2 and this 2 here. Okay, so that would be the square root of 2. Then I close. Then this is going to give me a value something like 0.20710678 1. Okay, what about our k2? K2 will be equals to 0.25. Now here, remember, it's f of ti. Okay, it's f of ti plus h over 2. So if you go to your calculator, you say h over 2, this right here, which is 0.25. So 0.25 divided by 2 is 0.125. When you add it to ti, what is your ti? Our ti is still, we're still dealing with t naught. Okay, that's going to be 2.125, comma, we have wi plus k1 divided by 2. So if you divide this value by 2, then you add it to this one, you're going to end up with some value. I'm going to write it. You can try to punch that on your calculator. Okay, so here we have more like f of, we have 2.125, comma, after dividing and adding, like you divide this by 2, you divide this by 2, then you add w naught. We are going to end up with something. Let me just write it here. So you have 2.125, comma, this part, remember, is like wi plus k1 over 2. When you compute that, you're going to end up with a 2.10355391, like that. Okay, so that's what we have. So this is going to happen, that this is equals to, we're going to say it's 0.25. So in a similar manner, the way we substituted here, like substituting in this differential equation, that's the same thing that I'm going to do right here. So this is going to be like minus 2.10355391 plus 2.125 times the square root of this same value again. So let me just try to copy it and place it right here. Okay, so this is what we get. So if you punch all of this on your calculator, okay, if you punch all of that on your calculator, you're going to end up with this value that I'm just going to write right here. So that value is going to be 0.24 4617098. Okay, so let's go to K3. K3 will be equals to K3 will be equals to 0.25 f of, on this part, if you remember, K3 is the same as K2, like for the initial, like the T part that you make a substitution for here. So it simply means it's also 2.125 comma, but for this part it changes. It's basically Wi plus K2 over 2. So we get this value here, we divide it by 2, then we add with Wi. What is our Wi? It's a 2. So when you do that, you're going to end up with this value right here. So what value is it going to be? So that would be more like 2.1 22 30 I think 308 549, like that is equals to. So even here in a similar manner, it will be 0.25 open bracket minus, you get this value right here, this one, you place it right here. So let me just copy it and also place it more like somewhere there. So it will be that plus the same 2.125 times the square root of this one right here. So if you punch all of this on your calculator again, you're going to end up with something like 0. This is our K3 by the way, 0.24 3 55577, stuff like that. Then our K4 will be equals to 0.25. Then you have f of. So for this part, for K4 is a little bit different. For this part, remember we say it's Ti plus H. So it's basically T naught plus H. What is our T naught? Our T naught is a 2. Our H is 0.25. So we put 2.25 here when we add them. Then for this part, it's basically K3. It's K3 plus it's more like Wi plus K3. So it's basically this value right here plus W naught, which is a 2. Okay, so when you do that, when you add them there, that's just going to be 2.24335577. Having done the same here is just more like a 0.25 open bracket, you get this same value here, which is this one. So I just copy it and just copy it and place it there. We place it there like that. Then what happens? Then we say plus, and by the way, it's a minus. And even in the previous one, I think I forgot to place a minus. It's a minus. So we put 2.25 times the square root of. We get this same value here. Okay, we get this same value. Then we place it right here, like that. So it's all about now working with your calculator. Punch that on your calculator. You're going to end up with some value like some value that is like 0.28 1664355. So we basically have everything that we need now. Okay, we have everything that we need. So we have our K1, we have our K2, K3, as well as K4. So it's just a matter of us coming up with the final solution, like our final approximation. So we know, or we have determined that our K1 is equals to, then let me also place K2 here is equals to, so let me just copy these values that we have gotten. I'll place this one here. Then our K2 is equals to, I'll place it there. Then K3 is equals to, then I'll say K4 is also equals to, so this one we place it right here. Then K4 we place it right here. Okay, so I can just erase this part so that we'll have some space to work with. Okay, so allow me to just place this one here, and I'll also place this one. I'm just copy this. So this one will be placed right here. So remember, we say how we determine this is that our wi plus 1 is equals to wi plus is 1 over 6, then this 1 over 6, then remember we have k1 plus 2k2 plus 2k3 plus k4 here. So it's just a matter of just substituting here. Then the way we are going to do that, we'll just say, remember, we used t naught is equals to 2, then w naught is equals to 2. So here it simply means our I was equals to 0. So since we are saying wi plus 1, what we do is that this will give us w1 because I is equals to 0. So this will be equals to w naught, which is a 2 plus 1 over 6. Then we have our k1, which is that value that we have here, which is this one. Then we place it there. Okay, then I'll say plus. So we have plus 2 times our k2, which is this value. I'm just placing it right here. Then we say plus 2 open bracket, then we have this, placing it right here. Okay, so remember we're also adding k4, which is this value that we have right here. Okay, we place it right here. So then we can close our brackets like that. So w1 is going to be equals to, if you punch on your calculator, this is going to be 2.244119414, like that. So this is our approximation. So we have determined that our w1 is equals to 2.244119414. Okay, this is what we have as approximation. And remember, the question was also asking us to make a comparison to the actual solution. So what do we do? So it simply means on each stage we need to compare with the actual solution. So at w1 we are dealing with t1, which in this case is 2.25. Okay, we are not dealing with t naught. So because at w naught, that's when we are dealing with t naught. w1 we are dealing with what? With t1. Of course, when I was finding w1, I wasn't using t1. I only use t1 when I'm looking for w2. Okay, so what do we do right here? So to find the actual solution, simply means we're going to say y of t1. What is our t1? 2.25 is equals to, open bracket, we're going to say 2.25 minus 2 plus the square root of 2 times e, then times e again to the power minus 2.25 divided by 2 squared. So if you do that, punch that on your calculator, you're going to end up with 2.2441211, like that. So if you find the error, okay, our error is going to be equals to this value right here minus this one is the absolute value, by the way. So we say 2.244119414 minus 2.2441211, and this is just going to give us something like 0.000001696, like that. So this is what we end up with as our error. So now, does it look like we are done? Maybe, but we are not done actually. So if you have observed, I've only worked out for t naught, meaning t naught gives me w1. Okay, so you need to work out for this one, you need to work out for that one, as well as that one, in just the similar steps that I took. First of all, come up with your values of k. So it simply means the way you are going to continue, or the way we are supposed to continue with the other, like going ahead, is since we now know to say we have determined our w1, so we're going to go to what, another step where we use t1 is equals to 0.25. Then we say w1 is equals to the value that we got, which was 2.244119414. Okay, so it simply means here again you have to start afresh, come up with values of k1, which is equals to h times f of, so here it simply means it to be t1 comma w1, like that. So our k2 will be equals to um, h times f of, you are going to say t1 plus h over 2 comma w1, which is what we are dealing with, plus your k1 divided by 2. You continue in the same order. K3 will be equals to h times f of, you say t1 plus h over 2 comma w1 plus k2 over 2. Our k4 is just going to be equals to h times f of, you are going to say your t1 plus h that you already have, so you have your w1 um, plus k3, okay, plus k3 there. So this will be our k3. So just continue in the same order after you are done with all of these, meaning these are going to result in you having w2. Then you go to this one, the 2.5, that will give you w3. You go to this one, that will give you w4, and that's in that order you are going to continue from there. And actually, since if you observe, this is going to be like 1 2 3 4, so you can actually end on this one as more like your final approximation, because it's just more like you need 4 steps. Why am I talking about 4 steps? Is because if you look at this, what you have right here, let me just try to erase this part. If you look at what you have here, remember your n tells you the number of steps. Okay, so your b minus a divided by h, like this. What is your b? Your b is a 3 minus a, which is a 2, divided by your h, which is 0.25. This tells you that you have what, you're going to have a 4. Okay, so it simply means the first step where you use t naught, that's more like the first step, or if you want, you can call it the step 0. I like calling it the 0th step. Then meaning t1, that's going to be the one that is like step 1 until you reach this one here, there, like that. Okay, so in that same order, just continue working it out, and let me just write what you're going to get as you proceed. So your t3 is, we said, is 2.75. so as you continue, you're going to determine that your w2, just highlight everything here, your w2 is equals to, or let me start with w1. So w1, we found that is 2.244119414. Okay, this is what we got together. So work out w2 the same way I worked out w1. So this you're going to end up with 2.56444487777. Then your w3 is going to be equals to 2.9651 391, like that. Then our w4, okay, w4 is equals to, so for w4, this is when you use this one here, t3, which is 2.75. You're going to end up with 3.451281186. Then w5 is going to be equals to 4.027938166. So by the way, the reason why it's more necessary for you to end on this one is simply because even as you are doing the comparison with the actual solution, remember this one right here, this is when t1 is equals to 2.25. This is when you have t2, which is equals to 2.5. So this one is when you have t3, which is equals to 2.75. This is when you have t4 is equals to a 3, like that. So I'm not talking about how you were coming up with them. Like when you're coming up with W1, you used what? You used T naught. For this one, you use T1, you use T2, you use T3. Here it's more like you use what? T4, which is this one. But when you're making comparisons with the actual solution, this one here, you compare with the actual solution. Like we're trying to come up with the actual value in the actual solution. You don't place T naught. No, that's wrong, because the one where you're required to place T naught is this one right here. So meaning you're going to compare with this one, not this one. So if in the actual solution I substitute T naught, I'm supposed to make a comparison, not with W1 but with what? With W naught, which is a 2. So for W1, you want to compare with the actual solution, you need to substitute T1. W2, use T2. W3, use T3. W4, use T4. Hence, it was reasonable why I was talking about us using 4 steps, because these are exactly what we need to come up with. So that's all in this video. Thank you very much for watching, and we'll catch you in the next one.